The US is desperate to cooperate with Russia over mining and production of rare earth metals. First of all, what is rare earth metals? Rare earth metals refers to a group of 17 elements including scandium, yttrium and the lanthanides, which are often used in high-tech applications due to the unique magnetic and chemical properties. Even though they are not actually as scarce as the name implies, they are considered rare because they are usually dispersed, and very difficult to extract in concentrated form from the Earth crust. Rare earth metals 15 lanthanides plus scandium and yttrium. Namely lanthanum, scandium, cerium, dysprosium, neodymium, praseodymium, yttrium, promethium, terbium, samarium, europium, gadolinium, holmium, lutetium, thulium, ytterbium, terbium. Russia has a massive untapped reserves of all the 17 rare earth elements. The United States needs them all, but the problem in extracting such element is no small feat. Production of metals such as aluminum and titanium is a whole art form on its own. To produce super-strong magnets for electric motors, wind turbines, microelectronics and aviation equipment, you will need neodymium, praseodymium to scandium. Russia's rare earth potential is endless. But there are multiple issues to overcome, to turn that potential into reality. China on the other hand has excelled in the production of such rare earth elements, but they slapped bans on some rare earth minerals to the US in retaliation to the restriction placed on Beijing. It took China over 25 years and huge research and development investments along with extreme environmental risk to get there. In 2019, at the height of the trade war with the United States, Chinese President Xi Jinping visited a rare earth magnet factory in Jiangxi province. At the time, the visit interpreted as muscle flexing by China's leader to remind Washington of its dependence on Beijing for the supply of rare earth elements. Rare earth elements are indispensable components in military defense systems, consumer electronics, and renewable energy technologies. Despite more than a decade of sustained effort by Western countries and companies to loosen China's grip, Beijing by far remains the top player in the rare earth elements global mining, processing, and refining sectors. Xi Jinping visit also conveyed a broader Chinese goal in the rare earth sector, that goes beyond mining, maintaining leadership in the downstream industrial supply chains of processing, refining, and magnet production. While the semiconductor war get more attention, there is another tech battle underway in the rare earth supply chains, as China continues to tighten its control over what it calls state resource, and its supporting technologies. The Western rush to build China-free supply chains with both upstream and downstream industries is masking the bigger technological challenge of establishing a sustainable processing capacity. Given the stakes, a targeted approach is required to solve the processing tech puzzle, through investments in research and development, international partnership, and diffusion of alternative methods. In 1992, while visiting Baotou, Inner Mongolia, one of China's biggest rare earth mines, Chinese leader Deng Xiaoping famously said, "The Middle East has oil, China has rare earths." He was referring to the country's resource endowment of over 30% of the world's reserves. But unlike the Middle Eastern oil-producing countries, who primarily drill and export crude, China built an entire ecosystem around rare earth, from mineral production and processing to manufacturing finished products and most importantly rare earth magnets. China has maintained leadership at every step up the ladder. Though, its global production share dipped from a staggering 97% in 2011 to around 70% in 2022. It still controls over 85% of processing capacity. China has an effective monopoly over processing major heavy rare earths, dysprosium and terbium, and light rare earths, neodymium and praseodymium. Environmental impact is often cited as one of the main reasons for China's emergence as a rare earth powerhouse, but the technological aspects is less discussed. From 1950 to October 2018, China filed over 25,000 rare earth patents, surpassing the US 10,000 over decades. Chinese engineers perfected the solvent extraction process to refine rare earth, which plays a critical role in ensuring China's primacy. Though the technology originated in the United States, environmental and regulatory concerns made domestic rare earths development unfeasible. Rare earths are clumped together in rocks, making their processing a complex undertaking. All of them behave the same way, with very minor differences in chemistry. That means they bond with the same things under the same conditions, and they are not going to separate from each other readily. China has mastered this process, while Western companies lack the expertise to achieve similar results. The two biggest rare earth mining companies outside of China, MP Materials and Lynas, have struggled to expand refining capacity, despite huge U.S. government investments, given the U.S. reliance on China for heavy rare earths, used in defense applications. The Department of Defense has provided millions of dollars to both companies and others to fully indigenize, mine-to-magnet, rare earth elements supply chains. Given the challenge of accessing China's control solvent extraction tech, and its environmental costs, multiple research projects are underway to search for cleaner and more sustainable processing methods. One of them is a DARPA-funded program called Environmental Microbes as a Bioengineering Resource, to use microbes to process and refine rare earths. A biologist and the principal investigator of the project, Marina Kalyuzhnaya, call it an intensive program, and argued that a biological approach could play an important role. The goal is to separate rare earth elements, and biology might be specific enough or selective enough to keep individual minerals out of the complex mixture. She added that the goal was to create something completely sustainable, but conceded despite exciting breakthroughs, scalability for the project is at least 4 to 5 years away. Apart from investing in new tech, the US and other Western governments have taken multiple national and international steps to diversify supply chains despite the effort. Benchmark Minerals, a mining advisory firm, projects by 2028, China's share in processing of both heavy and light rare earths would only drop marginally. There are many reasons for the sobering predictions. For one, Western governments are trying to focus on all stages of supply chains simultaneously without prioritizing one over the other, causing inefficiency and resource wastage. 2. Current policies divert attention from the bigger technological challenge of establishing sustainable processing and refining capacities outside of China. To resolve this, there is an urgent need to increase research and development investments for cleaner processing solutions that match or even surpass China's cumulative investment. The US also needs to address the processing know-how gap as a strategic technological challenge and not just a pollution problem. While state-led investments to spur private interest is essential, the bid to onshore all components of the rare earths elements supply chains would be counterproductive in the long run. The US, along with its allies, should create a rare earth elements-specific strategy, and foster development of regional nodes. It took China nearly 3 decades to dominate rare earth elements supply chains. A well-executed diversification efforts may not take as long. Russia plans to accelerate the development of its rare earth elements base, amid the ever-tightening sanctions regime against the country. To this end, the goals of import substitution in the rare earth element sector were included in the recently adopted Russian state strategy for the development of metallurgy until 2030. Previously large Russian state-owned corporations including Rosatom, Rostec, Norilsk Nickel and Gazprom, announced large projects for the production of rare earths and metals. But the task of import substitution is still far from being realized. The issue of Russia's dependence on import of rare earth elements has been repeatedly discussed at various levels. According to an earlier report prepared by the Russian Account Chamber, Russia imports more than a third of strategic types of mineral raw materials and more than 60% of various rare earth elements. As well, according to estimate of the Account Chamber, the need of the Russian economy for manganese, chromium, titanium, and lithium were fully met by imports. At the same time, imports covered 87% of domestic demand for zirconium, 40% for molybdenum, and 18% for tungsten. Back in December 2020, the Minister of Industry and Trade Denis Mancharov said that import dependence on rare earth elements should decrease to 50% by 2024. He did not disclose details, but the Russian Kommersant business newspaper, citing data from the Ministry of Industry and Trade, clarified that these plans involved increasing the production of rare earth elements up to 20,000 tons annually by 2024, and up to more than 70,000 tons by 2030. Particular attention will be paid to import substitutions of such minerals and metals as ilmenite, lithium, tungsten, molybdenum, niobium, as well as chromium and manganese. In the case of lithium, the largest investment project in this field, which are scheduled for implementation during 2023 to 2030, will involve the development of lithium fields at the Zavatinsky, Rosatom, Kovykta, Gazprom, Yarakta, Irkutsk Oil Company, Kolmozovsky and Polmostundrovsky fields. This, according to the ministry, should fully meet the domestic demand for lithium raw materials.